it's a very interesting conundrum.
I think just everything you've said, even just looking at the intensity of the population and how that's according to our use of energy, is so interesting and genuinely a conversation that we've had previous guests highlight before. Just kind of moving into this conversation of decarbonizing these heavy emitting industries that are necessary for industrialization. We see hydrogen, another silver bullet, kind of being demonstrated as key to reducing the emissions when we're looking at cement or general industrialization capacity. What are the future developments, if any, for blue hydrogen, which is a primary component of CCUS? What's that looking like at the moment? Are there any geographical plans going on? Any projects that are happening that, we could start applauding, almost looking into supporting hydrogen, for example, as a decarbonization element?
So, I know there's a lot of talk about hydrogen because, of course, hydrogen burns and indeed you get water. Basically, fantastic. Everyone likes that concept, but the question is, how do you create the hydrogen in the first place? Now, there are some people who are looking for naturally occurring hydrogen deposits, which great. I'm not going to address those. I'm going to address the two that are mainly talked about. So there's a lot of hydrogen created today, and it's called grey hydrogen. Yeah, and what you're doing is you're splitting methane by introducing steam, and when you do that, you get CO2 formed and you get hydrogen. And to date, a lot of people are capturing the hydrogen, but they're just emitting the CO2. So what you can do is you can put CCS on that CO2 emissions, capture the CO2, compress it, and store it underground. And that is what you do for blue hydrogen. Green hydrogen is where you use electricity to split water into hydrogen and oxygen. Now, the only thing is it's incredibly energy intense to do that. And so you need a lot of electricity to do that, to create green hydrogen. And in fact, you put a lot more energy in than you get out. So that's one of the challenges of it. And then another challenge of green hydrogen is, indeed, if I've got that much electricity, why aren't I putting that into the grid and decarbonizing other elements rather than creating green hydrogen? So these are, again, the challenges as you look at the energy system as a whole. And there isn't an easy right or wrong answer. There's a lot of trade-offs that have to be made. But even if you are going to move to hydrogen as being a big part of your new energy mix, you're not going to be able to build out green hydrogen at the scale quick enough to move large components across to hydrogen. Yeah. And so that's where making blue hydrogen comes in, which is, again, taking fossil fuels and splitting it into the hydrogen and the carbon component and storing the CO2. And then you have blue hydrogen. That you can do, and you can get to scale a lot quicker. You don't have necessarily the same level of competition between that amount of wind farms or solar panels being required to create green hydrogen and why aren't they going into the grid. And so it has a double effect there, that you can enable the hydrogen to get to scale quick enough that you can bring large industrial processes into looking at hydrogen as a solution. You can equally not necessarily take that much green power out of the grid in that sense. So you've got that piece. And the other way that I've talked to a lot of heavy industry about this is, well, actually, if you move to a hydrogen piece of your process, you mentioned steel and things like that, and you do use a DRHI in that sense, well, you could start off using blue hydrogen, and as we build out the power and the electricity grid enough to enable us to do green hydrogen, you won't actually feel the change. Yeah, it's still hydrogen coming into the plant. It may be blue today, and in 20 years' time, it's green, but your process stays the same. And so for me, it's a difference between talking about, if I come in and capture CO2 from an industrial process, from your flue chimneys, that's direct CO2 capture. Yeah, as in it's in your plant, on your processes. The other option is, indeed, you do what I call indirect CO2 capture, which is you shift to hydrogen, but it's blue hydrogen. We're capturing the CO2 before you burn it, in that sense, and giving you hydrogen. We take the CO2, put it underground. As the green hydrogen ramps up, you can mix blue and green together, and eventually, ideally, you could potentially swap over to fully green. Now, that's a long, long way out. But this, again, is a way that you can move through that transition, but you need CCS to help you do it as well. And then the other one you haven't mentioned is biofuels. There's a lot of talk of biofuels and waste to energy.